Welcome back to another episode of Matrickz Tech Talk. Today I'm excited to have Roy Fridman from Foretellix. Roy, welcome to Matrickz Tech Talk.
Thank you very much for having me.
So Roy is a passionate engineer. He has worked with startups in technology sphere, which has been acquired in the past by major companies like Samsung. Right now, Roy is taking care of the business development. He's the VP Business Development of Foretellix, a Israel-based company that is going to revolutionize the way we should test autonomous vehicle. So Roy, without further ado, why don't you tell our audience a little bit about yourself, your passion, your background, and
So, as you said, my name is Roy, and I was, throughout my career, I've been deeply involved and passionate about technology. I was an engineer doing work in many fields related to technology, whether it's software, hardware, different fields like communication. Then found my way into the very exciting world of automotive and automated systems in general. My last company dealt with sensor technology, which is also an exciting part of the challenges that we face when we are talking about automated systems in general. And now I'm really at the core of the challenge, which is how to test and validate and develop the product in the right way, which is basically the major challenge, I think, for the digital transformation of the world is going through right now with robotic systems. I would love to talk about that.
Fascinating. So I love the way you have introduced, and you already mentioned some challenges, some stimulating topics. So why don't we start from your company? What is the mission of your company, and what are you doing in the sphere of autonomous vehicle testing?
Foretellix's mission, or what we are trying to help with, is to help this very interesting transformation that is going around in the world on the automation of robotic systems. What we see happening, and this happens, inside very strongly in automotive, but actually in many fields, is that things become more automated. Whether it's trucks driving in a mine, or whether it's warehouses being automated to be more efficient, without need of human intervention, or whether it's driver assistant systems that help the driver make the right decisions and help them, assist them in the driving, and of course fully automated driving. All of these, we call it digital transformation. And in order to make this happen, there are a couple of challenges on the way. Some of them are related to technology, some of them are related to the cost of the process. But I think the major barrier to make sure that you get the full potential of automation in any field, including, of course, automotive and ADAS and AVs, is the ability to safely and validate that the systems are working properly, that they can handle all of the different scenarios that they face. Basically move from an approach of I'm testing a very mechanical system to I'm testing a brain. I'm testing a digital system that is extremely complex, and I need to validate it in millions and billions of situations.
Fascinating. So with that, can you explain to our audience a little bit when you say millions and billions of situation and cases that we have to cover? How big can we imagine the dimension would be if we were to test AV in a regular way without any simulation or any kind of advanced technology? We have heard requirements like we need 10 trillion miles. We heard requirements like 7-8 trillion miles. So without debating how much we're actually going to need, we can all agree that we're going to need an enormous amount of testing. It is just not probably even doable in a road environment for people, because not only because of the gigantic nature of the data that we'll need, that is on one problem. Besides that, we want to also test corner cases, edge cases, right? And that is not even ethical to try it out with a human driver in it. And we're also risking the entire environment. So how do you think we can solve this problem? First of all, can you tell us a little bit about this dimension? How big the dimension is? What for our audience to understand? Because it's enormous.
It is enormous, and in order to understand how enormous it is, you need to take, for example, yourself and any other audience as the case study, just to understand the enormousness here. We as drivers go out on the road. Think of all of the situations that we encounter in every minute, and all of the driving decisions that we make every minute that we are on the road. And now think about, some things that are intuitive to us. And then think about what will an autonomous system need to do and what decisions it will need to make by itself, to deal with the road situations. So many things can happen to you. It's very easy to kind of imagine a cat jumping into the road, a child with a ball, that's being thrown away. Different weather conditions that you need to drive in. Think about driving inside an urban environment with all those situations going around you. This is a massive undertaking, massive challenge with so many situations that can happen. And basically what you are doing, and for me, it helps, simplify things. You are taking a brain and you basically are testing a brain. Think about how many neurons, how many things a brain can decide to do, and this is a major, on the dimension part, this is a major undertaking, a major challenge.
I can totally agree with you on that, because if you think about the complexity of not only human brain, the sensors we have, our eyes and the way we feel and we hear, all these things combine, and then we have ADAS, an extension of our sensors. It is an enormous amount of data that we're processing every millisecond. It is hard to extrapolate that in an environment where we're depending on microchips that is doing our computation. Now, talking about testing, let's talk a little bit about edge cases. Even if we think about the regular things that we do, it is enormous. But if in terms of edge cases, it is not even possible to replicate that without putting people's life in danger in the street, right? So the only way we can handle those is simulating. What do you think of that? So can you tell us a little bit about edge cases?
It's definitely a major part of this question about how to validate automated systems and driver assistance systems, because when we go on the road, and company X wants to validate their system, they will put it through what you call the normal procedures and the normal scenarios that we can imagine that can happen to us. But our imagination as humans is relatively limited, right? It's not, I believe that we as humans cannot conceive all of the crazy situations that can happen to you. And also when talking about driving on the road, even if you as an OEM or as a company that develops ADAS, think that, I will test my system on the road, a lot of the edge cases actually will not come directly from there. There will be some kind of a manifestation of combinations of synthetic simulation that you will do together in order to find all sorts of cases that you were never able to think about. And maybe I'll give an example, okay, to help illustrate that. Think about the trucking company that needs to test long-haul drives, and they need to test a merge into a highway, right? Sounds like something that any testing engineer or any company will test if they are testing truck that will drive in a long-haul driving. Now, I want you to kind of imagine the vast number of situations that are merges into a highway. A merge can come from the left, you can have a car from the left, you can have a car from the right. You can do it in different weather conditions. You can have merges in 6 lanes or merges into a 5-lane road. The numbers are enormous. But let me give you one that maybe you wouldn't be able to think about. For example, a merge into a highway through a gas station, right? I'm talking about a real case, actually, that we have encountered during our, let's say that our system created for one of the customers, which was an interesting case that I can share. So think about you doing a merge, the truck doing a merge into the highway, but think about that it's done through a gas station. And think about the gas station having a roof. And then because of the roof, the sensors have some kind of issue moving from darkness to light. And then this creates a collision. Now, the customer engineers might not have been able to think about this kind of a situation. They were only able to think about, I want to test a merge into a highway. Now, what you need in order to actually deal with the complexity and scale of this testing is you need a system that will be able to create all of the merges into the highway that a human cannot think about by themselves. And that is partly what Foretellix is able to do, to create all of these unimaginable situations that us as humans, we will only be able to say, I want to test a merge into a highway. But we will be able to very easily create millions and millions of merges into a highway. So you can say, I have tested enough merges into a highway, so I feel comfortable enough to deploy the system.
Fascinating. So with your solution, I'm able to generate scenarios that is beyond human thoughts in a sense. I mean, it might be possible, but it's going to take enormous amount of time. And that is fantastic. So how do you execute those test cases? Is it a simulated environment, or what is the testing procedure?
Foretellix, in general, chose the philosophy of Foretellix, let's say it like that, is that the execution platform or the testing platform is not just one. It is a combination of a number of testing platforms, which first of all comprise of different simulators. We are completely simulator agnostic in our philosophy. And the reason for that is that different simulators are good for different things. One simulator can be very good for modeling the sensors, and one other simulator can be very good at modeling the vehicle dynamics and the tire friction on the road. Our philosophy, or at least our validation platform, connects to all of the different testing platforms, like the different simulators, but it doesn't neglect the information coming from on-road data. So we also connect to the logs coming from the actual street driving. And then what we do, we generate all of these scenarios, automatically using very deep technology on how to actually do it. It's not very simple. And after we do that, we collect all the information from the different simulators and from the street driving data and from the test tracks, for example, we also connect to these. And we analyze it for the customer and tell the customer very clearly in a dashboard of safety, here are the things that you tested. Here are the things that you are still missing. Here, you have not done enough left turns in the rain. You have a coverage hole in all of the testing that are related to driving on a 6-lane road and doing an unprotected left turn while driving on the snow. So we are like, you can look at us like maybe the conscience of the tester to tell them, okay, this is still missing, so you need to continue iterating and creating more millions of tests in order for you to actually properly validate the system.
So if I understood you right, you are completely platform agnostic or simulator agnostic. It is fascinating to me. So with your system, I'm able to generate enormous amount of test cases, and then I can take it and put it in any platform I want to. So that kind of reminds me of SOTIF. How do you think your system can help people who are dealing with SOTIF, the safety of intended functionalities? And the current version of SOTIF, they talk about test cases, enormous amount of test cases. So I have a lot of clients. We're talking about generating test cases, SOTIF-related test cases. And this is where, if you think about the entire V model, most of the money goes on the right side of the V model in testing. So tell me a little bit about, your approach and how can this be applicable to SOTIF? This is going to help some of my clients for sure.
Yeah, so this is an excellent question. First of all, we are deeply involved in all of the regulation and standardization efforts in the world, but this is a topic for another podcast. One of the things that we have contributed actually into SOTIF is the mention of the need for coverage as a means to understand where you are in the process of your validation. And what I mean by coverage is that, you talked about miles a lot and how many miles are needed, but I think that you will agree with me that miles by themselves are pretty meaningless metric, because 100 miles in the desert is not equal to 1 mile in San Francisco, right? So we have actually introduced another concept that is called coverage, which talks about what scenarios were implemented and not the number of miles driven. So this is one contribution that we are working on inserting into SOTIF. I believe it's already in the last draft. And to maybe to your point about how we can help. So one of the main challenges in SOTIF is dealing with the unknown unknowns. How do you expose these unknown unknowns?
Totally.
And when you are looking at the current methodologies and the current tools that are out there, they are talking about more statistical approaches, talking about trying to use some kind of optimization of parameters and all sorts of techniques that are very mathematical in order to create some form of understanding of, let's call it, what is the optimal driving situation, what are the right parameters. Our approach comes from semiconductors, and it is called coverage-driven verification. And coverage-driven verification is the art of finding the unknowns. Let's call it like that. We have invented it in semiconductors, and today, all of the companies like Intel, Qualcomm, Apple, all of these companies are actually using this proven methodology to help them find unknowns and interesting bugs that happen to them inside the semiconductors. What we have done, we have adapted these methodologies and tooling into the world of robotic systems and autonomous systems. And one of the key elements, or one of the most powerful elements in these methodologies, is how to find these unknown unknowns, because the bugs, the real interesting bugs that we are talking about, will not come from the standard situations that you experience on the road. Or for example, like a cut-in. These will not be the very interesting bugs. Where will be the interesting bugs? They will be that while you are doing a cut-in, exactly at the same time, one of your sensor fails. And or another combination, that when you replace the battery system in the car, for some reason it creates an interruption in your navigation system, and your car starts driving on the left side of the road instead of the right, depending on which country you are working from. These things are not something that you can find by using just mathematical and statistical approaches. These things can be done by using systems like Foretellix that use a random approach, constraint random approach that looks at and explores the whole space of scenarios. And by that, finding all of these very strange edge cases, mostly in simulation, of course, but also connecting to test tracks and other physical elements.
I love that. So what you're saying, SOTIF goes beyond failure. So ISO 26262 was focused on failure. SOTIF is, okay, even if I don't fail, I'm taking input from my environment. And what if it is not what I intended? Now, the example that you give is kind of like, you're mixing failure also with the intended functionality. Like the sensor is failing, but my intention is that. That is something that is really fascinating, and I think this is going to help a lot in defining those scenarios.
One of the things you have just said is actually a very good keyword, which is mixing. One of the concepts of our system, and actually it is in our language on how to describe scenarios that now is on its way to become a standard, is the ability to take 2 scenarios or 3 scenarios or 4 scenarios and mix them together. For example, you can take a cut-in scenario and you can mix it with the car coming into a junction scenario. So you have a cut-in scenario and the junction scenario, and you can mix it with a weather scenario or with the sensor fault scenarios. Now, all of these scenarios are very simple scenarios that a human being can create very easily, can think about. But what happens with systems like Foretellix is the ability to mix between them creates a whole space of crazy edge case situations automatically that the human would never be able to think about alone. So when we mix the junction scenario together with the cut-in scenario, we suddenly get out of the millions of scenarios that we have created, one situation in which the car cuts in from the left. And then for some reason, there was an issue with the car that comes into the junction that they started to swivel or something, do something else. And then you get yourself an edge case that never happened in reality and solved you a problem or a bug that you have not been able to think about alone.
Fascinating in that sense that, we'll discover scenarios that we will never think in real life edge cases. And if you want to take measure for this or not, what I wouldn't want to do is I would want to know what are my risks out there, even if the risk is the probability of that happening is low, but I want to have the test vector as broad as possible. And that's what your tool is doing. Can you tell our audience a little bit about measurable safety? Because that is what I hear is the mission statement of Foretellix.
It is definitely a huge part of the mission statement. And I think what we are trying to do, and this is a big challenge, this is not a simple challenge, especially to when you are a thought leader in this industry, in this area, we are trying to help companies and the general ecosystem quantify what is safe. We are trying to introduce new metrics that will help you understand what is the right definition of done. Today, there is a lot of focus on whether the car performed in the right way, whether it did the right thing, whether it passed or failed. And this will remain forever. I mean, this is a super important part of validating the system. But we have introduced another metric that comes from semiconductors, our background world, and this is called functional coverage. And what is functional coverage? Functional coverage is whether I've executed, whether I've tested what I wanted to test. Now, this sounds very simple, right? I want to do a cut-in scenario, and I want to do a close cut-in scenario, close to the device under test, like to the autonomous vehicle. Now, if I wanted to do this test, right, this sounds like trivial that this actually happened, right? So the answer is no. And why is it no? Because your system under test has a brain of its own. It will decide to do whatever it wants. And what I mean by that even if I want to create a cut-in scenario very close to the device, to the autonomous vehicle, the autonomous vehicle might change a lane. It might brake and decide to stop in the middle of the road. So now I'm putting you a question. How do I know that I tested what I wanted to test? And for that, we bring another type of metric system that is called functional coverage. And this is an ability for you as the developer of the system, or maybe even for a NHTSA as the regulator, or for insurance companies to have a report, a very clear report that tells you, you have only tested 50% of the cut-in scenarios from the left. You have a coverage hole. You have not tested all of the dangerous scenarios of the cut-in that are very close to an accident. Are you ready to deploy this system? Are you as an insurance company willing to put your insurance on this AV stack? Are you as a developer willing to come out with a system that was only 50% covered in terms of what it was tested? So this is a new metric. We are we have introduced it to the world, and what I can share about this metric of functional coverage. In semiconductors, this is the way that you decide whether you are ready to go out and put the chip into silicon and take the risk that you have a bug inside that can cost you hundreds of millions of dollars if you make a mistake. So this is what we're trying on the measurable safety side. This is what we are trying to bring to this industry, and it's relatively, I can say, well accepted so far.
So you have generated the test scenarios. Now we have a simulated environment. Any types of simulation, be it sensor simulation, whatever simulation, you're agnostic to that. I love it. Now, the question is, we need simulation, but we also need to test the simulated results, validate them in real life. So that is going a little bit beyond probably Foretellix, but being an insider of that industry, test industry, how do you think we can achieve that? You know, these edge cases that you're talking about, near accident scenarios that you're talking about, if we can test it in the simulated environment, and after the simulated environment, we need to validate in real life. And what should be the proportion between simulation and real life? And how do you think we can achieve that?
I fully agree with you that there needs to be very strong correlation between the simulator and the actual drive and what actually happens on the road. Because if the simulator would not be accurate enough, you will not get very valid information from synthetic simulation data, from the verification that we are doing virtually. So actually on that, Foretellix helps a lot because our system is basically connected both to real driving logs of what happens on the road and also to the virtual simulators. So you can kind of correlate between the results that you are getting on the road versus the result that you are getting inside the simulator, and then know whether this simulator number one is providing you with good data, or whether simulator number two is providing you with good data, or simulator N. So this is actually a very important part of the process. I think that 95% of the validation, even more than that, will be done in virtual simulation, but the 5% will serve as the foundation to make sure that the correlation between what happens in real life and what happens in simulation, there is a strong and very accurate correlation between them. This is the way that at least Foretellix sees things.
We have seen numbers that if we want to do it in real life, we not only will have to spend enormous amount of money, but we may take probably 500 years to cover the entire scenario, right? Now, even if we talk about 5% in real life, 500 years, 5% is 25 years. How do you think it would be even possible to test this 5% in real life? What we do is we see AVs roaming around in our suburban area, OEMs testing them, and the ADAS functionalities are launched based on those kind of testing. But this is like, it's one thing to drive around the nice suburbs of Munich and test it. Another thing is the edge case scenarios that you're talking about. And what would that 5% cover? Because you talked about coverage, you know, the quality. It's not the quantity, we need the quality. We need the types of test cases in that 5%. Can we talk a little bit about that 5%? How realistic is it? And what's your thought on that?
So I think the 5% can come from different, let's call it different elements. It can come from the street driving that, you see all the Waymo cars and the cruise cars driving around. And of course, also on ADAS, there is many physical driving, much physical driving as well. And you can look at test tracks that all the companies have that you can run around relatively safely there without risk of injuring people. And you can look also at hybrid solutions like HIL, hardware in a loop, that you put your car in like the real car inside like a garage, and you kind of test it not in the fully simulated computer environment, but a real hardware in a loop. So you have different measures and different levels of testing that you need to do out of the 5%. So you can do like, I don't want to, give exact numbers, 5% was just an estimation, but overall it will be like gradual. When you reach the road, okay, when you reach the actual road, you better be very well tested by then and not use people as, let's call it guinea pigs. I know that there are some companies that have, that are more inclined to actually use real driving as testing environment. I don't believe this is the right approach. I think that you need to very well validate the system in the virtual environment at the beginning, then move to hardware in a loop, then move to proving grounds, and only then, when you feel safe enough, you can start validating it on real driving. I see it as a gradual approach.
Gradual simulation, hill environment, and eventually the actual road.
I don't believe that edge cases can come, by the way. I think that edge cases can come from the real world, for sure. It can happen. But I believe that most of the edge cases will come from massive virtual validation. I think that this is also a change that is happening now, that people understand, or companies understand, how much they have not tested in terms of virtual validation, how many edge cases are hiding around there in the virtual world. I think most of the things will come from there.
I want to take the conversation to a slightly a tangential domain. So, in your scenario definition, do you consider security at all? Like, there can be attacks. That can be a scenario, right? Do you consider that?
The scenario description language that we have, this language that is now becoming a standard, on it, at least the base for the standard Open Scenario 2.0, we believe that everything can be a scenario, including cybersecurity scenarios, including sensor fault scenarios, including everything that you can think about can be a scenario that can be described in this human readable language. Of course, like any technological development, there are phases. So we start with the most important things, which are the vehicle maneuvers, then you add the pedestrians, then you add the bicyclists. So it's like MSDL and Open Scenario have, let's call it a roadmap. But if you look a little bit further away, we believe that this language will basically cover all of the different type of scenarios that you can conceive.
So I will tell you first my observation. So our company operates in the cybersecurity and safety domain in the automotive industry, and the cybersecurity hasn't been as much as I would like to see. The OEMs hasn't invested as much as I would like to see them investing in cybersecurity in the last 10 years. And since one or 1.5 years, I see a slight bit of changes. It's going up. What is your thought on that? Why is cybersecurity not been taken that seriously? And where do you think the future is going?
It's a good question. Everything is related to the general advancement of technology. I think that the technological advancement, although relatively, impressive, what happens, it's still gradual. So, we have been talking about the need, for example, for LiDAR sensors for a while, but it will take time until they get adopted inside the cars. And the same thing also relates to, I guess, developments in other areas like cybersecurity and safety and so on. These things will gradually be introduced and kind of be adopted, I guess, by OEMs as long as, in some kind of a gradual process. Nothing happens, in just one shot, you have everything. Because if this was the case tomorrow, Volvo would come out with a car with the 2 LiDARs, the 10 cameras around it, 5 ECUs that are in charge of cybersecurity, prevention and so on. So it's a gradual process, I guess. That's my take on this.
I love it. So, Roy, I heard that you have some big news coming up from Foretellix. Would you like to talk a little bit about that with our audience?
For us, it's very exciting that Denso, the second largest tier 1 in the world, has selected Foretellix's validation and verification and product development technologies as part of their, as their infrastructure. This came after a very successful pilot that we had with Denso, and I believe this is another, let's call it proof of validation of our technology and our direction, and that such a very respected tier one is actually, taking very seriously our approach and tools.
Congratulations on that. So, in their testing environment, so they're gonna generate scenario using your tool, and also your consumers. Can you tell us a little bit, I mean, as much as you can without giving away any confidential information? Can you tell us a little bit about what is it gonna do with your technology?
We have done a pilot together that we have shown the usability and the advantages of our tools to be able to find all of these edge cases and do massive virtual validation, and they liked it. And now we are working on deployments in different areas that are related to verification and validations within Denso. I cannot share too much about this, of course, but overall, I can say that Denso will utilize the tools and methodologies of Foretellix to help them be best in class in verification and validation.
Gotcha. Is your tool more relevant for OEMs or tier ones?
Our tool is relevant for OEMs, for tier ones, for insurance companies, for regulators. So it depends on what aspect of the tool you wanna look at, because there is the aspect of I am the developer of the autonomous stack and I want to validate my work and do it efficiently and quickly. On one hand. The other hand, if you look at the OEM, they need to make sure that they are, as the system integrator, are getting a validated autonomous stack, and then they are testing it in their entire infrastructure with the right sensors, and the whole system operates properly. And then you have the TÜV SÜDs and the compliance companies that need to make sure that these OEMs and tier ones adhere to the levels of compliance that are needed. And then the insurance companies need to reinsure the OEMs and tier ones so they will not be, the liability will issues and with all of that. So we are basically supplying a solution for the entire ecosystem, entire tool chain, you can say, entire ecosystem. And each one of the, let's call it ecosystem players, can use our system at a different capacity, but all of them can gain a lot of value from what we're doing.
Fascinating, Roy. I think my audience would be very, very interested in a little bit detail of your tools and technologies. So I want to go a little more specific. Let's stay within the SOTIF environment, SOTIF context, because this is what we do, and I'm pretty sure most of my audience would be familiar with that. Now, we want to define some SOTIF test cases using your tool. What will be the workflow? Will the engineer come up with certain scenarios, and then your tool will mix it, so to say, in a randomized way, or is it going to generate automatically? What would be the workflow in a very high level, of course? We don't want to get into the,
Yeah, we have two different use cases. So Fortify, the Foretellix tool as a platform, is basically an open platform that any engineer can basically write scenarios and do everything they want by themselves. We integrate into the OEM or into the tier one or into the, the different AV developer platforms, and then they can decide by themselves whether they want to generate the scenarios alone. But what we also offer at Foretellix is what we call verification and validation packages. And what it means is that we already provide you with the basic content that can generate all of those millions of scenarios by itself. For example, we have created a package for highway driving. So a trucking company or someone that tests the level 3 highway pilot system can just take this package, click on a button, and then automatically he gets millions and millions of use cases and edge cases that validate its system. And everything is, derived because of the concept of the language and the tools. Everything is derived from customer experience, from accident databases, from all sorts of different disengagement reports. So we collected all of these and we put it in a package, what you call, and then the customer can also decide to use the content that Foretellix is creating. And this is relevant for highway, we created a regulation package, for example, that is called an ALKS package. There was recently a release of the new ALKS regulation, the first level 3 regulation in the world for automated lane keeping systems. It was released by the UNECE, and we have actually created a verification package that tests your compliance to ALKS, basically, to this regulation. This was done in cooperation also with, in testing with Mobileye. We have done a joint demo in which we test the system using Mobileye's RSS technology. And these verification packages or this content, we will also be able to provide to OEMs and tier ones and all of the rest of the ecosystem to give them value as well.
I love that. For my audience, you mentioned this open, anyone can go and put a test case. You said it's Fortify. Is the right word?
Fortify is the platform that is able to generate and analyze the scenarios, and MSDL or Open Scenario 2.0 is the language in which you write all of the test cases.
Amazing. So I think it would be very helpful for my audience to provide a link to those two things in the description below. The next question that I would have, we covered SOTIF, we've covered most of the stuff. Roy, is there anything that you would like me to cover that I haven't covered yet?
Maybe one topic that I want to raise is the question of what it takes to do massive scale simulation or verification on that regard. I think there are many challenges that are very apparent to us right now, about how to mimic the sensors in the right way in the simulation, or how to make sure that inside the simulator, the tire friction is correct. But I want to also kind of entertain the thoughts of your listeners on other challenges that might, that are very important challenges, such as the challenge of usability or reuse, or the ability to actually deal with millions of scenarios. How do you do that? How do you create a library of scenarios that can scale up to millions of test cases? How do you deal efficiently with the uncontrollability of your device under test? I mean, think about the testing engineer sitting there in Daimler, for example, and he's trying to test something. He's trying to create a scenario of a closed cut-in, like I described before. And he's trying and trying and trying. And every time that he tries, the autonomous vehicle decides to brake and doesn't let him do the testing. So we can spend days only on one scenario that he's trying to create. You need systems that are able to automatically and dynamically guide you into achieving your goals, into be able to reach this scale. And the scale is one of the biggest challenges there when you are talking about actually deploying these systems. How do you achieve scale? How do you do it efficiently? How do you do it without hiring 1 million engineers to write test cases for you in a very concrete way? So all of these questions are questions that, OEMs, tier ones, AV and ADAS developers need to ask themselves. And I think that Foretellix in general and Fortify platform has an answer to a lot of these questions.
I love it. So what you're saying is we do ask questions like, the physics behind the simulation. Are we talking about the physics? And traditionally, automotive industry simulations, as we have seen, is based on game engines. And if you have played Counter-Strike, you see sometimes that you're actually walking through a wall or something. Yeah. So game engine is not physics focused. It's more the graphics and everything. So what you're saying is more important is the scale than the physics itself.
I'm saying that both of them are important. Mm-hmm. I'm saying that some questions that needs to be asked are also related to the ability to achieve scale. Not only focus on the physics and on the accuracy of the simulator, but also think about the ability to run and validate efficiently millions and millions of scenarios. This is a huge challenge that some of the most advanced companies in the world still have not been able to reach very good answers in some of these questions. And I think that this is a major question that needs to be asked and we can help with.
Is Fortify a cloud-based platform?
Yes.
That is fascinating. That means that, even a startup can come up with their concept and leverage your platform to validate their concept.
So Foretellix, yes. The answer is that we work in both ways, also on-premise with the cloud of the customer. We work on the cloud in general, on AWS or Azure, on these type of clouds. So at the end of the day, the solution is meant for scale. So it's definitely a cloud-based solution. I know you have probably heard that we have acquired a company called Metamoto, which is a simulation company in essence. We have done this acquisition, officially announced this acquisition, a couple, months or two ago. And basically, one of the advantages of this acquisition was that Metamoto provided, let's call it a simulation as a service. They were very cloud-oriented as a company. And some of their technology is also integrated into Fortify as part of our constant improvement in being able to run at scale on a cloud infrastructure. So the answer is definitely cloudism is a key to scale, that's for sure.
Fascinating. I would want to ask you one last question. So we're at an era that is on the verge of being transformed into something that is enormously important for mankind in general. I think there were like two major things that happened in the past: industrial revolution that changed the society, information technology revolution changing the society still, digital transformation. And I think AV will not only be a digital transformation, it is going to go beyond. It's going to change our life. That's another major changes, technological changes in the history of mankind. Now, with that technology coming up, what do you think would be the best thing that would bring for mankind, and what would be the some negative scenarios?
In a lot of areas, we will reach or get a lot of improvements in productivity. For example, in the trucking, in the AV trucking, being able to work 24 hours, trucks hauling goods, and in mines, doing the work. So the productivity is huge for that. Of course, the second major thing is the safety, being able to avoid accidents that today, are caused by drivers that are driving on the road. So reducing accidents is also a huge benefit. In terms of drawbacks, I'm an optimistic guy. I don't have anything in mind right now on the drawbacks. I just it's only a question of when it will arrive. It's a gradual process. I don't believe it's like one day we will see autonomous vehicles on the road. And right now, for sure, we are still not fully prepared for this. But any advancement that we will get, for example, in ADAS, a system that helps the driver change lane in a safer ways, will suddenly reduce the number of accidents, or a truck that will be able at least partly to drive around and productively haul goods, this, if it will give 20% or 30% efficiency boost or productivity, that's great. So it's a gradual change. It's a very important change. I agree with you. This is like the industrial revolution in terms of size, what it will bring. So I'm very actually excited for this industry.
Fascinating, Roy. So more productivity and more safety is what it is going to bring. And with that, Roy, thank you so much for being with us. It was lovely having you.
Thank you so much. Great to be here.
Thank you so much for watching or listening this podcast. If you have any questions, comments, feel free to write in the comment section below. If you have liked it, please feel free to smash the like button. And for Open Scenario 2.0 and Fortify, we have put the links in the description below. Please feel free to browse, and if you have any question, please write in the comment section. Would love to get back to you. Thank you so much for watching.